And we're starting with our warm-ups for today on the yellow paper. So today's warm-ups, the two we're doing today, are number 3 and number 4. Let's take a look at number 3 first, okay? So Dave has $358 in his bank account, and he wants to prepay his cell phone bill for the next 3 months. Let me write that down, 3 months. His monthly cell phone bill is $78.50, and he also needs to pay his electric bill, which is $135. How much money will Dave need to add to his account to cover the bills? So what kind of strategy do you guys feel like using in this? Subtracting? Okay, so let's start with what we have. We have $358, and we're going to subtract what?
Subtract $135.
$135 for the electric bill, and we also have to subtract what? How much for that phone bill?
$78.
That's for 1 month. How many months is he doing?
3.
So 3 times $78.50. Okay? There's different strategies you might have used, but this one is absolutely valid. So let's look at our order of operations, GEMS. I don't see any groupings. I don't see any exponents. What do I see?
Parentheses.
These parentheses, which indicate what operation? Multiplication. So let's go ahead and take that -3 times $78.50. Somebody put that in their calculator. Tell me what it is.
-3
Times $78.50. 78.5.
-$235.
So that's -$235. Ooh, that sounds like it might be 0.5. Can someone verify that, please? -$235.50. Okay, I still have that electric bill, and his balance is right there. Okay. Now we're at the point where the only thing we have is add and subtract left to right. So going from left to right, let's take this first one. What is 358 minus 135?
223.
223. Can someone verify that?
Yep.
So he has $223 left in his account, and he still wants to pay $235.50 toward that cell phone bill. So go ahead and let's subtract that and see if he has enough money or how much money he's going to be in the hole.
$11.50.
$11.50. Somebody double check that.
Pardon me.
I think we got something different this morning, but that might be just about right.
Well, negative.
That's what we got this morning. What did you get? Yeah, so -$12.50. So if it's -$12.50, how much money does he have to put into his account? So he needs to deposit $12.50 so that he doesn't bounce any of his payments. $12.50. Okay. Our next one is talking about somebody named Amy. Amy borrows $132.72 to buy supplies for her birthday party, and she receives gifts and money from her friends and family. The total amount of money that she receives is $250.50. How much money does she have after she pays back what she borrows? Who can set up this expression for me? How much money does she actually have? $250.50. And that money that she owes, when she owes it, is it a minus or a plus?
Subtract.
It's a subtract. So minus 132.72. There's only one operation I see there, so I don't even really have to think about my order of operations. What is $250.50?
117. 178.
117.78. Someone verify that. Yes? So 117.78, is that what you said? 78. That's how much she has left over. All right. Remember that you're going to box, circle, or highlight your answers in some way so that when you turn it in, I can see what your answer actually is when I'm grading it. Okay, so that is the warm-up for today. You can put the rest of them back. We are going to continue those combining like terms notes that we began yesterday. So go ahead and get these notes out, put the yellow pages away, get the white copy of yesterday's notes out. All right, so if they needed to pause the video, hopefully everybody's got the notes back out. And yesterday we did the combining like terms at the top, and we discovered that in algebraic expressions, like terms have two important things in common. Like terms have the exact same variable, and that variable is raised to the exact same power or exponent. Okay, you should have filled this in yesterday. A variable with no coefficient has a coefficient of what? 1. So if we don't see a number in front of it, we assume that it's 1. Terms take the plus or minus symbol right directly in front of it or to the left of it. And plain old numbers or constants, you can write it either way. Numbers or constants, those are like terms. We discussed it yesterday. I'm just going over it. We also went through and saw which terms were like terms in this. We said that the 5x is like the 2x because they both have the exact same variable raised to the exact same power. And when I sectioned it off, I made sure to include the symbol in front of it. Okay, we also said that this positive 3x squared could be paired up with the negative x squared because they both have the exact same variable to the exact same power. Now, we also said that since this is a plain old number, positive 20 and negative 9, that those could be matched up. Now, to finish these notes out, what we're going to be doing is we're going to be practicing that with a little bit of it. So let's look here. We're picking up with simplifying each expression. So if I can only combine things that have the exact same variable raised to the exact same power, what do I circle? What goes with y? All the other y's, right? That positive y and that positive y and that positive y. How many positive y's do we have altogether? So that we're going to write as 4y. Now this plus x down here, I can't ignore it. It doesn't go away. In order to keep this an equivalent statement, it has to be included, but it cannot be combined with the 4y because it is not a like term. It does not have the same variable. Make sense? All right, let's move on to the next one. The next one, my first term here is 3x, so I'm going to start with that. Are there any like terms to 3x? Exactly. I like that you said negative in there because the negative does go with the x. Okay? So if I have 3 x's and 1 negative x and I combine them, how many x's do I have left over?
Negative 4.
That would be if we're multiplying it would go negative. But right now, just think of it. We're adding those coefficients. So 3 and minus 1. So what is 3 and minus 1 when I put them together? 2 x's. Now let's see, I've got a positive 2y right here. Can that be combined with the positive 7y? Yes, because they both have the exact same variable raised to the exact same power. What is 2y's and 7y's? 9y's. Okay, we're rocking it out. Let's do the last 2 examples, and then you're going to be working on some on your own for a few minutes, okay? So, looking down here, so it doesn't really matter what order I put them in because they can be in a different order and it will still be equivalent, but kind of the polite thing to do in the math world is to start with the biggest power. You don't have to. If you write it differently on yours, that's fine. But me, out of habit, I'm going to go ahead and start with let's start with my positive 8x squared. What term is like 8x squared?
Positive 2x.
So good. Positive 2x squared. So if I've got 8 of them on the left and 2 of them on the right, altogether I have 10x squared. Now, I have one that's just got a plain old variable. I've got this one right here, negative 3x. Can I combine that with the 5?
No.
Why not?
Because it doesn't have the same variable.
It doesn't have the exact same variable. But I cannot forget about it because it will make my expression not equivalent anymore. I got to keep it. So negative 3x, I'm just going to copy down like a list. And then that leaves me with that 5. I don't see anything in front of it, so I'm going to assume it's positive. Just write plus 5. So the trick here is that you only combine things that are like terms and that you can't lose anything from one to the next. If it doesn't have a like term, that's okay. It gets listed. Okay, finally, the last one here. Let's start with this negative 4x. Okay, negative 4x. Is there anything that I could combine with negative 4x? No, so I'm going to write negative 4x. I do see a 2z here. Can anything be combined with 2z?
Yeah.
Positive z. So if I've got 2 over here and 1 over there, altogether I have 3 positive z's. And then finally, there's that lonely little positive 9 down there, but I can't lose them. I got to keep them. Okay? How do we feel about combining like terms? Pretty good? Halfway? Sometimes it can feel complicated just because you have to be very careful and very exact. However, it's just as simple as adding and subtracting because this is not ever going to be what we're talking about when multiplying and dividing. Okay? This skill that we're working on specifically applies to adding and subtracting. So when I'm saying combining like terms, I'm only talking about adding and subtracting like terms. Okay? So on the next page of your packet that you have is some practice, and we are going to take approximately 10 to 12 minutes and we're going to work on these. So the first page, I'm going to tell you right now, somewhere on a corner, write 17 total, just so you remember how many you're looking for. So including the one that's already given, there's 17 total of these. And what you're going to do is you're going to try and find 3 in a row that can be combined and give you an accurate statement. For example, here they found a diagonal with 5x and negative 3x. If I combine 5x and negative 3x, I get 2x. So I can circle this. It's like a crossword, but for math, okay? Now, there's other ones in there, but don't be fooled by ones that go like, let's see. Let's look at this one right here. This is an example of what not to do, okay? So I have negative 20, this one right here. Negative 20y plus negative 8y gives me what? Negative 28y. This looks like it should be, but look at the variable on there. Is it to the exact same power? No, so that would not be a correct answer. So let's see if we can find a correct one. Oh, look right here. Look at the very top left corner. So up here, I have negative 4x and negative 11x. So if I take negative 4x plus negative 11x, I would indeed get negative 15x, okay? So there are 17 of those on this side of your page. So your goal is to try and get those done. When you finish with those, we've got just on the other side of the page, we've got some simplifying like terms. Identifying like terms and simplifying the expression. So that's like what we just did on our notes, okay? They might maybe have some fractions mixed in there or decimals, but it's the exact same thing that we just did, okay? So goal number 1, cross math. Goal number 2, simplifying. You've got 12 minutes to work on that, and then I'm going to ask you to stop that so that we can move on to the notes for the distributive area, okay? I'm sorry, we're not doing the area. We're just doing distributive notes today. Any questions? All right, so I'm going to go ahead and pause this so they can also pause the video this afternoon. Okay, guys, I've resumed the recording. So listen. So I want you to hold on to this paper with the cross math and the simplifying these things. We're going to come back to it later this week. So don't recycle it. Hold on to it. We're going to be doing that at odd times throughout the week. But for right now, we're going to go ahead and make sure we get through the distributive property notes and practice before the end of class, okay? So, distributive property. Here there's a little side note that tells you that distribute means to give out, okay? So when I'm thinking distribute, this is going to be a function of multiplication. It's going to be a way that I can use multiplication even when I've got a grouping that doesn't have stuff I can combine on the inside. So far, when we've had a grouping symbol, we've been able to like add or subtract until we get it down to one single number. But sometimes when we have variables, we're going to end up with something inside of a grouping that is not that easy to simplify. So let's look at a few different strategies to handle this. The first strategy here is it says we can rewrite grouping inside the parentheses the number of times that the outside term shows and then combine like terms. So like, for example, if I read this would say 3 groups and each group is x plus 8, okay? So on your notes, let's write this out. Ready? So I'm going to write 3 groups of x plus 8. So I've got x plus 8 plus x plus 8. And then one more, plus x plus 8. Because we know that all multiplication is just repeated addition, right? So that works. Now all we have to do is simplify that. So let's see, how many x terms do we have? I've got one right here, one right here.
3, 4.
Look at it, how many?
3.
3. So I've got 3 x's. Now, how many 8s do I have? 1 positive 8, another positive, 3 positive 8s. So 8 plus 8 plus 8 is?
24.
There you go. Now, I can't simplify that anymore, can I? Because they don't have exactly the same variable raised to exactly the same power. Therefore, they're not like terms. So, boom, that is it. That's as far as I can go. Look, easy enough, right? A lot of writing, though. There's a faster way. Do you want to see the faster way? Okay, so let's look at this. The faster way is you can take the number on the outside of the parentheses and you can multiply each term inside. You can multiply each term inside by that number and it's going to give you the same result. So let's look at this. If I have 3 times the expression x plus 8, it's telling me that I can take this 3 and multiply it times the first term and the second term, and it will give me an accurate response. So what is 3 times x?
3x.
What is 3 times positive 8?
24.
Positive 24. Did that give me the exact same answer? It did. So that's writing it using multiplication. I personally would normally write it out using the multiplication, the distributive property. And you're going to use this a lot. And not only are you going to use this a lot, but we're going to use the inverse of this. And that's what we're going to be focusing on over the next few days is the distributive property so we can get good at it enough that we can do some factoring. So let's do these together really quickly, and then you're going to do the rest of them on your own. So looking here, if I take my 4 times x, what do I get?
4x. 4x.
What is my next term?
Plus 10.
Not plus 10. That's times 10. 4 times 10. So what is 4 times 10?
40.
Plus 40. And I cannot combine 4x and 40 because they don't have the exact same variable raised to the exact same power. So I'm done there. All right, let's look at this one. 5 times y. What do I get? What's my next thing that I multiply?
5
5 times 2.
5 times 2.
is 10.
10.
10. Positive or negative?
Positive.
Positive. Okay. Let's look at the last example together. So 2 times what first?
7.
2 times 7e is how many e's? 14 e's. What do I take my 2 times next? 2 times 5m, and that gives me what? 10m. Positive 10m's, negative 10m's, what? There you go. All right. So your mission now is there are just 9 little practice problems. Hey, I want to do one other one together just because it gives us a little bit of a different thing. I want to make sure we see it. Everybody skip over to number 9 really quick. So here we're going to do the exact same thing. There's 3 terms in there instead of 2. Samesies. Doesn't matter. So let's take our 12 times our 2e. What do we get? 24e. Now I'm going to take my 12 times what next? 12 times a positive 1f, and I'm going to get a positive how many f's? Now, here's what I want you to notice. When I take my 12 times this, do you remember that we take the sign in front of the variable? So this is not just a plain old v. We're looking at a negative v. So I've got to take 12 times negative v. How many v's do I have?
1.
How many?
1.
Nope, look at it.
12.
I have 12 v's, but I've got a negative right here, and my 12 is positive. So what do I do when I take a negative times a positive? What sign do I have? Negative. So that one's going to become negative. I don't think any of the others deal much with switching signs, but remember you can use all the different methods. We do have this method is one that you can remember right there too, where if I take a negative and a positive, I'll get a negative. If I take 2 negatives, I'll get a positive. We have like 3 or 4 different strategies. Use the one that's best for you. Okay, does anybody have any questions on this? Okay, the goal for the end of this hour is to get the rest of this filled out. When you finish, you will probably have a few minutes left. That's when you're going to go back to your cross math puzzle and this, okay? Your cross math and your simplifying page on the white note sheet. So, first things first, distributive property, and then with any remaining time, go back and finish cross math. We good? What's your question?
On number 4 is the n.
On number 4 is the n. Ooh, yeah, that is another one. On number 4, we're going to take 8 times 2m and 8 times negative n. Good catch. Any other questions? All right. I'm going to go ahead and stop the recording now for later in the day, and you guys are going to have the rest to work.